Okay, this is a short video tutorial for a clever way of approach for generating a frame structure in 3D Experience. These video tutorials are intended for people who want to make a transition from the ABAQUS CAE program to the 3D Experience platform, uh, or the people who are novice and they want to, so they're starting with the 3D experience in the first place. The revision of this software that I'm using is 2022x, and uh, the reason for specifying the revision is that the software is transforming very quickly. Some icons are added, some functionalities are changed, etc. Now, if you are uh, proficient in using the ABAQUS CE program, you should know that the native FEA solver in the 3D experience is actually the ABAQUS program. However, the icons, the interface, and essentially the platform is completely different in 3D experience. And therefore, uh, the way I operate in this playlist is that I find uh, problems that are done with the ABAQUS CAE in a step-by-step fashion on YouTube, and then replicate the same steps or the approach at least in the 3D experience platform, and this will show people how the two softwares are different. Essentially, they're the same, but they're different on the face of it. Okay, so uh, the problem that I'm doing is actually done by this YouTube channel, by the Simtech05 YouTube channel, and it's very, very nice. He's coming up with a way of generating a simplified uh, model of a transmission power. Now, notice that transmission tower on the top is rather, involved. It's time consuming essentially to make this whole thing. So Simtech 05 is actually making a simplified model of that, but the approach is the same. So what you see in the middle is actually what this reference is generating. Now, I will do the same thing, except that I will not cut this thing into, let's say, here you have basically 1, 2, 3, 4, 5 bays. So I'm going to do only, let's say, 3 bays, okay? The way this is done is that the top is generated, and then this uh, drafted pad is created, so as a solid, and then split with these reference planes, so that you get basically, in my case, 3 layers, in his case, 5 layers, okay? Now, this can be done in the part design uh, workbench in 3D experience, uh, but I will but the splitting of the solids is not straightforward if you go that route. It's easier if you do it in the generative shape design. The solid can still be generated and still cut. Okay, so let's go ahead and do the problem. This is done. Let's go here. Notice that I'm in generative shape design. So on a convenient plane, on the top plane, XY plane actually, I will draw a 1 by 1 square. Let's draw a 1 by 1 square, something like that. Let's make it 1 meter by 1 meter. Since my units are in millimeters, I put down 1 meter here. Okay, and the same thing down there. 1 meter. Okay, and then exit. All right. So here you have in the tabs, although this is generative shape design, and in the CATIA program, it is coming from the CATIA software, as you know. Surfaces can be handled, but there's also the volume piece that can be created. There is a volume tab here. So notice that there is the volume extrude. So I'm going to click on this thing. and I'm going to, this is extruded upwards, so I'm going to extrude it down by clicking on this, by this reverse, basically reverse direction, and I put 10 meters, 10 meters, 10 meters, oops, 10 meters. Okay, there we are. Except that this is not padded, so I'm going to use sorry, this is not drafted, so I'm going to use the draft option here. You click on this. It asks you for a few things. First of all, it says the angle. Let's make a 5-degree angle. However, this reference, it starts with 5 degrees, and then it says that, oh, I'm going to change it to 3 degrees. This being the case, I want to change this thing to 3 degrees, just like Simtech 05 is doing. Now, we are supposed to select the support. The support of these four faces on the side. So these are the ones that are going to get drafted. Let me turn this thing around. So these are the four faces that are going to get drafted. Actually, the support is that entire extrude or basically padded volume. Okay, and then it's asking for the neutral surface. The neutral surface is the one that is the drafting is going to start from. So that top face, and I'm pretty sure preview. It looks like that. It's kind of hard to decide what this thing is going to do. But let's say okay, and you see that the solid is generated with the top being 1 by 1 meter, and it's 10 meters long and 3-degree angle. Okay, so what you see here is essentially that piece. Okay, now because I want to cut this thing with, I want to split it, partition it, etc. I'm going to create two planes. Now remember that this reference is taking 5 planes. Okay, I'm going to do only 2 intermediate planes. So let's go ahead to the essentials. You can create a plane offset from the XY plane in the reverse direction. So let's go a third of the way down. So that's going to be so 3.33 meters basically. Yeah, that's the first plane. Then I'm going to do another one from here. Again, flip the direction and 3.33 meter. Okay, so what you see here is actually these planes, except that he's doing 5 of them 2 meters apart, I'm doing 2 of them 3.33 meters apart because the process is the same. It just takes longer. Okay. All right. Now you see here the split. So if you go to the volume, if you go to the volume, uh, you should be looking for a stream split, but the split is not actually in the volume, it's in the transform. If you look at the transform here, and there's a split here, split. Now you read this thing carefully. It says element to cut. Element is to cut is that entire volume that we generated. A cutting element is that first plane. And notice that we're going to say keep both sides. See that? Keep both sides. All right? And we say, okay. So now what has happened is that this volume is partitioned into 2 places, 2 pieces. So I'm going to repeat this thing again. So element to cut is now the bottom piece, and cutting element is that plane, bottom plane, and keep both pieces. And we say, okay, good. All right. The next thing is to extract, following the procedure suggested by Simtech 05. I'm going to extract these edges. Now, extraction is, let's see where we can find it. It is on the wireframe. Go to wireframe, and let's see if we can find extract. If it's not there, go to transform, and extract must be somewhere here. Let me see for a second. Volume surface. Let's go to essentials, and there's extract. Okay, so it's under the essentials tab, extract, and patiently start extracting these edges. Now, you can control, you can see what you have extracted by clicking on this bag and putting it on the side, and you see what happened. So let's start. 1, 2, 3, 4. And if you want to extract the top, let me see now, the top edges, so such as this. Oh, we don't want this. We don't want the surface removed. Did I do it? That surface I will remove. Okay, good. So let's do this edge and that edge. Now you can see why I'm not taking 5 planes, because this thing is just time consuming, that's all. So here, this edge, that edge, and this edge. And now let's go to the other edges. 1, 2, 3. This is the 4th one. Let's do the sides. So here's the edge here, and there, and there, and there. Oops, we don't want this last one. So go down here. This last face I want to remove. It's just the edge that I want to take. There may be a faster way of doing this thing, because there's an option called propagate, but you see the remover. Let's try it again. But I'm doing it manually, okay? And the side edges, if you want to extract them. Actually, you know what? I'm not going to extract these last two. We don't need it. I don't need it. So let me remove this. Yeah, and remove the last one. Remove it. Okay, good. Okay, so we say close, and we say okay. There we are. Okay, now the next step. First of all, I can, by the way, hide the solid. So let me see now. So if you go here, let's see now. Let me see. Hide this. Okay, and actually, let's say hide that and hide that. Makes easier to do the rest. And these planes also, it's better if I hit them. So these 3 planes hide, and these 2 other planes hide. Okay, good. Now the next thing that this reference is doing is actually doing the uh, uh, these side members. Okay, so let me do that. So we go here to let's go to the wireframe, select the wireframe, and notice that beside the line, you also have the polyline, okay? So what you do is we want to create, for example, something like this. Start from the bottom here to that, zoom in, to that point, and to this point, and to this point, and finally back. Actually, let me see for a second. So we go 1, 2, 3. I think this one, we know these 3 of them. This one, let me remove this because I'm not sure whether okay, so let's go ahead and do that, sorry. And then it goes down there. Okay, good, good, good. All right, so we say okay. and do it again for the top bay, So let's start with the top bay, which is over here. So once again, polyline, it goes from this point to this point, this point, and up to there, and down to here. So, okay. And the last one is over there, starting from here to this point on the top, this point, that corner point, and down there. Okay, he's also creating some cross members here. So let's do that. Now, again, well, we can use polyline or line. That's entirely up to you. Let me do line here. It's easier. From this point to this point, and then from this point to this point. Well, we have to do this thing one at a time because I didn't double click on this. So let's do that from there to there. Okay. Okay, and then from here to here, and from this location. So okay, and then because I double clicked, it doesn't close it. I can go ahead and do the other ones. Now, a couple of comments here. Actually, cancel that. Let's do it again. From this location to this location. And click again, and from this location to this. Let me zoom in. From this point to this point. Good. Now, in that reference, in that ABAQUS CAE reference, it is something that the fellow is not doing, and it may be that in ABAQUS, in the ABAQUS CAE interface, that's okay, but not in 3D Experience. Notice that these two lines eventually are going to get meshed with beam elements, and right now they go over each other. So what I'm going to do is I'm going to split. See, notice that when you select this, the entire line is selected. When you select the bottom one, the entire line is selected. I don't want this. I want to be a break here. Okay, so we go to the once again to transform, and there was a saw here. See that split? Okay, here you have to be careful. I want to split this line with that line and keep both. And then this line with that line and keep both. So there should be 4 pieces here. See that? This is one line. If you zoom in, you can see that. This is one line is selected. Here's another line. Here's another line. And the 4th line. And I have to repeat this for the other pieces. So we go down here. So I'm going to split this line with that line and keep both. And this line with that line and keep both. Let's check it out. Let's see whether we did it right or not. One line, two line, line 3, and line 4. And finally, let's try the bottom one. Now that's something that he's not doing, and it may be that in the ABAQUS program, I don't know, somehow it works, but not here, this and that, and keep both. Let's check it out. So line 1, line 2, line 3, and line 4. Okay, good. Now, to make my job easier, I'm going to join all of these. Okay, so we go to on the transform icon, on the transform tab, you select join, and you make a window around this. Instead of picking them one by one, you're going to join all of these, because when you mesh it, everything is going to get meshed. When you apply, cross section, everything you're going to apply to that joint, everything is going to have the same cross section. And if that is not the case, then you have to, change the appropriate members. Okay, so we say fine. Okay, here you get this message, and it's because of these check marks. See that it doesn't like these two check marks. You say fine, un, uncheck these, and then say okay, and there won't be a problem. So a join has been created down here. You can see that. Okay, let's apply material to it. Because I'm going to actually run it. I'm going to actually, he's not doing it in the reference that I showed you. I'm talking about Simtech 05, but I will actually run the problem later on. So I'm going to mesh it and apply properties and things like that. So let's go ahead, first of all, to tools, and let's create a material. Let's call it a frame, the frame structure. All right. It's right here, right click, apply. We close that, apply it to the part, say OK. And let's put properties of steel in it. So it's structures, ABAQUS multiphysics. It's a static problem, so we're not going to put any density there. So we go elasticity and 200,000 megapascal. 200, 200,000 MPa. That's 200 GPa, and 0.3 of 0.3 for Poisson ratio. Very good. So now we're going to go to the generative structure analysis, actually structural model creation. Some reason I thought about it here. Structural model creation, and we're going to do a empty mesh, empty FEM. Okay, let's do the meshing. So click on the mesh icon. See that? Mesh tab, beam icon, and let's make it. Now this top piece was 1 meter, so we're going to make every element 20 millimeter. How about that? So yeah, okay, it's going to be a very fine mesh, but that's okay. Mesh, and this is a linear type. The support is that join. The support is that join that I created, right there. And then, okay, it's going to mesh it. Now, if you want to see, right-click, visualization, or visibility manager, and this means don't show me the part, just show me the element. Show me the element right there. Show me the element. What's going on here? What's it saying? Model. Let me, before doing this thing any further, so let me update first. Okay, there we are, because I had not updated it. The part is not showing, but the elements are showing. And if you zoom in closely, you see, these are so small. Actually, you know, I'm not happy with this, so let me make it a lot bigger. So let me go to beam mesh, and instead of 20 millimeter, I make it let's make it 200 millimeter. Okay, that's a lot more respectful. Now notice that because of what I did here, that point is actually a node. If I had not done this splitting of these lines and keeping both sides, for example, then these lines would have gone over each other and there would not be a common node here. Now, in that reference, it could be that Abacus is treating it differently. I'm not sure. Okay, so let's go ahead and apply properties. So properties. Now for beams, first you have to create a profile. So I'm going to make a circular profile here. This is the beam profile, dialog box, circular. And I'm going to make this thing maybe, how about making it just for visual purposes? I'm going to make it also maybe 100 millimeters. Okay. So we did create a profile. Now we're going to create a section. So beam section. Support is that join once again. So let me move this thing out of the way. The support is the join. And the profile is the beam profile that I created. And notice that because I made the cross section so big, you can actually see what's going on. Okay. We're going to hide this thing in just a minute. But anyway, this is shows the story. Now, if you don't want these things, so don't show me the properties, hide it. Notice that I can hide it. And also, if you don't want to see the mesh, you hide it. But then the part is not showing, so just say show me the part. There we are. Okay, good. So that's fine. So let's go ahead and run it. Apply restraints and loads and run it. So we go to structural models, structural scenario creation. Let's select our finite element model. It's a structural, of course, analysis. It's a static problem, so click on the procedure. It's a static problem. Since it's a linear problem, all these defaults are going to be fine. And then for the boundary condition, let's clamp the bottom four edges, four vertices. So here's the clamp. So this vertex, not that edge, cancel. Remove, zoom in. You can always filter it so that other things are not picked. For example, let me see now, vertex selection. Okay, so even with this filter, you can't select these other edges. You can just select the vertices now. Okay, let me do the following. Let me cancel that. I'm having some problem picking that point. But let's first of all let's look at the visibility. See what we got. Visibility manager. So we have the shape, which is the part. That's okay. That's good. So under boundary condition, I want to select this vertex. There, it's selected. It looks like I'm just using the selection arrow. That's it. Two vertices, three vertices, and the fourth one. Four vertices. So these are going to be clamped. You can see that in the tree, these four vertices are clamped. It's right here. And then I'm going to apply a load, some load up there. So let's go ahead and apply, for example, a load. So under load, I'll do a concentrated force. Let's say to this vertex. Okay. In the coordinate system given, so that'll be, for example, in the direction x. X, I put a minus 1000 This unit is Newton, so that's okay. Now it's not much, so let's put it actually 10,000 Newton, okay, like that. And that's it. So we go to simulate. First, we do a model check. And then we do a simulation check. This is to get, the model check is the equivalent of the data check in the ABAQUS CAE. A model check and scenario check, simulation check basically is the equivalent of that data check there. And then when you want to submit, here you say just simulate, okay? Well, there may be some errors, not errors, I hope not errors, but some warnings, that's fine. Okay, that's good. And I'm going to run it or simulate it, and we'll see how it goes. As the that gentleman in the Simtech Simtech 05 channel, YouTube channel, saying is that I mean, obviously, one way is to create the points or read it through Excel file and then create the members, etc. But this is a clever way that he's proposing for creating a more relatively complicated geometry. There we are. So yeah, so let's look at the deflection. Let me close this thing and let's look at actually the deflection displacements. So you can see there's very tiny displacement here. It's about 0.2 on the top millimeter. Now that's 0.2 millimeter, less than a millimeter. So remember, these are rather thick pieces of steel frame that are perfectly welded each other, etc. So it doesn't move that much. So this stresses are going to be fairly uh, uh, small, small also. That's pretty much it. So good luck. I hope you find this thing useful if you're trying to transition to the 3D Experience program.